we are moving on to the next couple of rules. And so moving on to 7.4, we are doing the division properties of exponents. So technically the way this rule works is if I have x to the m divided by the same base x to the n, we keep our base and we technically subtract our exponents, the top minus the bottom. That's what the rule is written for, or as. So if I were to have, let's say, 3 to the 5 over 3 to the 2, I would keep my base and take my exponent, the top one minus the bottom one, which is 3 to the third power, which is 27. The reason this works, and I believe this is how you guys used to do it before you got into the rule, 3 to the 5th means I have 3 times 3 times 3 times 3 times 3 divided by 3 squared. So then you can cancel those ones that are the same, and what does that leave you with? 3 to the third power, right? Which is 27. So that's why the rule works. Unfortunately, not always is the top exponent bigger than the bottom. It might go the other way around. And so we're going to talk about it a couple different ways today. Okay? So a lot of times what I might end up saying is if I have x to the third over x to the 7th, I might say to you, where do we have more x's, on the top or the bottom? On the bottom, so that's where I'm going to put my x. And how many more do I have on the bottom? 4. So technically you subtracted that, right? That's what we did. We have 4 more on the bottom. What would be left on top then? Perfect. That magical 1. All right, so let's actually get into using this rule in our homework today, right, to start with. Yes. Exactly. Yeah, that's the reason it works. And we can always use some shortcuts, right? All right, here we go with example number 1. And this is going to be in the very first section from 12 to 22. We're going to do a few of them in this section. Just going to ask you to simplify. All right, so let's say I have, how about 6 to the 4th over 6 to the 2nd. Where do I have more 6's? On the top, how many more do I have? 2. It's the same as keeping my base and subtracting my exponents. And then 6 times 6, of course, is 36. All right, now I know you guys got that, so let's make this a little bit tougher. Right? What if I had x to the negative 4 over x to the negative 2? First thing I'm going to suggest is we need to get rid of those negative exponents. So we've got to flip them. Exactly. Very good, Cooper. So this one's going to go to the bottom, and this one's going to go to the top. So I have x to the positive 2 on top and x to the positive 4 on the bottom. Now where do I have more x's? On the bottom. How many more do I have? And what's left on top? Perfect. Okay. How about this one? What if I have, how about a to the 3rd, b to the 10th over a to the 7th, b squared? All right, we're going to start with our same base. So we're going to start with our a's. Where do I have more a's? On the bottom. So I'm going to put my a on the bottom. How many more do I have? Perfect. 4. Okay, let's go to our b's. Where do I have more b's? On the top, so I'm going to put my b on the top. How many more do I have? 8. Perfect. All right, what haven't I included yet? A fraction or a coefficient in front, right? So let's add that in there. Let's say I have, how about 8x to the third y to the 0 over 16 x y squared. All right, let's look up there to begin with. What is the very first rule we learned? Y to the 0 equals 1, right? So what rule do you think we should start with?
Probably that one.
Probably that one. So this right here, y to the 0, we are going to get rid of that. That equals 1, so that's gone, right? All right, now we're going to start with our coefficients. Right here. What goes into both 8 and 16? 8, very good. 8 goes into 8 once. 8 goes into 16 twice. So right now I have 1 over 2. Go to our x's. Where do I have more x's? On the top. Put my x on top. How many more do I have? 2. How do you know that, Carter? There's no number on this one. There's that magical 1. Very good. All right, and I only have y's on the bottom, so where do you think the y's have to stay? On the bottom, so I have y squared. All right, so before I go to the next example, do we have any questions so far? No? No questions? We're doing really good? Awesome. Let's go to example number 2 then. Still from those same group of problems, okay? We're going to simplify, and we're going to get it just a little bit more going on. Let's say we have k to the 1/2, j to the -3 over k to the 1/4, j to the 2nd. We'll do that. All right. So remember our exponent rules. First one we learned was the 0 one. Do we have that up there? The next one we learned was the negative exponent one. Do we have that up there? So that's what we should start with, right? We're going to take this j to the -3. We're going to move it to the bottom. And we already have j's down there. So right now I have k to the 1/2 over k to the 1/4. I have j to the 2nd, and I brought this j to the 3rd down. So I have j to the how many? To the 5, right? Because there's 2 down there, and I brought 3 more down to join them. All right, are we all clear there? We're good? Okay. So now we've got to look at where do we have more k's? On the top, absolutely. So I'm going to put my k on top. Question is, how many more do I have? 1/4. Good job, Eva. 1/4. How did you get 1/4? And you subtracted them? Very good. And then I have my j to the 5th. Do I have any other j's? So it's just got to stay where he's at. So even if there's a fractional exponent, does it change our rules? Doesn't change our rules at all, does it? All right, let's do one more in this example. How about let's go 10 x to the 5th, y to the -2, z to the 3rd over 5 x to the 7th, y to the -9, z to the 0. Huh? Okay. Cooper, where do you want to start? Good. Z to the 0. Right here equals 1. That's gone. Okay. Now what do we want to do next? Good. The negative exponents. So this one right here, this y to the -2 has to go to the bottom. and y to the negative 9 goes to the top. All right, so I have 10 x to the 5th, y to the 9th, z to the 3rd over 5, x to the 7th, y to the 2nd. Are we all good? Okay, so now we're going to start at the very beginning of our problem with our numbers. 10 over 5 equals what? 2 over 1. All right, I have 2 over 1. We're going to go to our next thing that's the same, which is our x's. Where do we have more x's? On the bottom, so I'll put my x on the bottom. How many more do we have? Excellent, 2. Now we go to our y's. Where do I have more y's? On the top, so I'll put my y on the top. How many more do I have? 7. And last but not least, I have my z to the 3rd. Where does that go? Stays on the top. So we just put all of our rules all together. Didn't even notice, did you? That's great. Any questions? No, we're okay so far? All right. Then let's talk about scientific notation. All right, when you're doing scientific notation in the division world, first you're going to divide the coefficients. Then we keep base 10, that's a P by the way, base 10, and subtract the exponents. And then of course, make between 1 and 10. All right, so let's say I have, start off with 3.5 times 10 to the negative 4 divided by 7 times 10 to the negative 2. So the first thing we do is divide our coefficients. Starting right here, 3.5 divided by 7. What is it? Okay. It is 0.5, but remember we're leaving it all in decimal because that's scientific notation, right? 0.5. We keep our base 10, and remember we're going to subtract our exponents. Now I wrote it that way so that you could see negative 4 minus negative 2. What do we have going on there? We've got a sandwich, don't we? So it's really negative 4 plus 2, which is negative 2. Now, is 0.5 between 1 and 10? Too big or too small? Too small, so we're going to be subtracting from our exponent. We have to move it over 1. So we get 5 times 10. Whoops. Didn't write that very good. Sorry about that. 5 times 10 to the negative 3. All right, so questions before we get into an example from here. Okay. All righty then. Here is example number 3, which is going to cover problems 24 through 32. All right, how about we do um 4.9 times 10 to the 7 divided by 7 times 10 to the negative 3. All right, so we start with our coefficients. 4.9 divided by 7, 0.7, times 10. And again, my exponents are 7 minus a negative 3. So it's 10 to the what? 10 to the 10th, right? Because we have a negative sandwich going on. All right, is 0.7 between 1 and 10? Too big or too small? So I'm going to subtract from my exponent, and I have to move it over 1. So I get 7 times 10 to the 9th. Questions on scientific notation? No questions? Okay. Now let's talk about our last rule today. All right. Our last rule has to do with a fraction with a negative exponent on the outside. Now, technically, we've talked about this. You would give that negative exponent to everything. Well, what's going to end up happening if I have a to a negative exponent and b to a negative exponent? They flip places, right? So our rule can actually be that we're going to flip them and make our exponent positive. Okay? And then, of course, we're going to give that exponent to everything on the inside. So, for example, let's say I have 2/3 to the negative 3. Because it's a fraction, and I have a negative exponent, I'm going to flip this to 3/2 and make my exponent positive. We're all good with that rule? Then we are going to give this exponent to everything on the inside. So we end up with 3 to the 3rd power over 2 to the 3rd power. 3 times 3 is 9 times 3 is 27. 2 times 2 is 4 times 2 is 8. All right. So now let's see how this is going to play into our homework today. Here's example number 4, right? Example 4. This is out of that last wonderful section of 34 through 48. Again, I'm simply going to say simplify. And how about if I have 1 over x to the negative 4? So first we flip it. So you get x over 1, technically, to the positive 4. And then we distribute that 4 to everything on the inside. And we get x to the 4th. Any questions before I keep going? Yes. Yes, we could. So right here, I was just showing you how it flipped. I probably, in my work, would not write that either because there's this magical 1 in the bottom. It's a good question. Anybody else have a good question for us?
So, hey, hello.
Uh-huh.
Do you want us to put, like, the x, the parentheses with x and then 4? Like, before we put the x?
If you can go straight from this one and flip it over and make it positive, I'm okay with that. All right? Okay, let's try this one. What if I just had 1 over b to the positive 3? Does that one flip? That one doesn't flip. So what's the only thing I have to do? Yeah, I got to distribute that 3 to the 1 and to the b. So I have 1 to the 3rd over b to the 3rd, or 1 times 1 times 1 is 1, b to the 3rd. All right, so can I make it a little harder? Can I step it up? Yeah? Yeah, everybody's excited. Yes, let's step it up. Okay, trying. I was trying. 6n squared over, so let's go with 3n to the negative 3. Well, that looks like fun, doesn't it? So we can do this one of 2 ways. We can simplify inside first and then flip it, or we can flip it first and then simplify. Flip it first? All right, we're going to flip it first. Okay, so first we're going to make this 3n on top over 6n squared on the bottom. What happens to my exponent? Becomes positive. Very good. Now let's simplify on the inside before we distribute that 3 to everything. 3 goes into 3 one time. 3 goes into 6 twice, right? So right now I have 1 over 2. Where do I have more n's? On the bottom. How many more do I have? Just 1. I'm going to write that 1 there for now, but I don't have to. Okay, any question how we got to there? Okay, then we're going to distribute that 3 to everything on the inside. So we get 1 to the third, 2 to the third, n to the third. Remember, an exponent raised to an exponent, we multiply our exponents, right? All right, on the top, 1 times 1 times 1 is 1. On the bottom, 2 times 2 times 2, 8. We have n to the third. So here's the one thing that's going to help you guys. Doing each step without trying to do like all 4 rules at once is going to make it easier for you. You'll make less mistakes. I know you want to skip some work. I get it. But because there's so many different little things going on, you've got to do it step by step. Okay? Do we have any questions? All right. So we are on page 442 and 443. 12 to 48 even. All right? You still have 20 minutes in here, almost 20 minutes in here. So you can go ahead and get a lot of it done. I want to be able to walk around, check and see how you're doing. Okay? And then tomorrow we'll probably do a review over the same rule before we keep going. Okay? So no worries. We got this.